Good morning to all of you. Today we are going to discussing about the unit 3. Unit 3 is completely about the entered level measurement, flow measurement, right? Level flow measurement. So this complete unit today we are going to discussing about the. So now it is okay. I will increase the sound. Okay, now it is okay. Number lateral ante 326. You said that voice is slow, sir. So 1 minute. So now it is okay. Babu, number lateral ante 26. Lateral ante 26. No. Is it any some other person? It is audible to all of you clearly. It is audible clearly. Any some other persons? Okay, but here, Mr. 326. Better check. Of course, maybe the internet issues. Maybe some problem in the internet issues. So that's why maybe the voice is somewhat slow. But all other remaining members said that it is okay. Okay, best check na, Mr. 326. Your name is Manipalle, right? Right. Okay. So we'll go for class. Uh, so now here today completely this unit is about that level measurement, flow measurement, and also speed measurement devices. We are going to discussing about level measurement sensors, pressure level flow measurement sensors, and speed measurement sensors. So these three. So each and every level, flow, and speed, maybe 4 or 5 sensors are there. We'll discuss one by one. Okay, right. We'll go for here. Some problem is coming for video camera. All right. Okay. The next, this is the introduction. Level measurement. We will discuss about the working of various instruments. That is various sensors or transducers. That is which is used for the measurement of level. That is a capacitive sensor, ultrasonic sensor, magnetic sensor, cryogenic fuel level indicators, bubbler level indicators, right? So these are the totally 4, 5 are there, 5 instruments in our syllabus. So for the measurement of level, and in flow measurement, that is rotameter, magnetic meter, ultrasonic meter, hot wire anemometer, laser Doppler anemometer. So in this is also totally 5 are there. 5 instruments which is used to measure flow and speed measurement devices. And speed types of this is a tacho. I think all of you know that mechanical tachometers, electrical tachometers, stroboscope, and non-contact type of tachometer. That is four. The here in these 4 devices, 4 instruments, we'll discuss about that speed measurement. See here, in this, the first we will go for introduction of a level measurement. Here in the level measurement, measurement of level of a liquid. We can measure uh, liquid level measurement, for example, in a tank. Here in this, actually, level, anybody can define the level. Anybody can define the level? Level. Anybody? Level. Level. Limit. Right. Quantity of substance change from initial position up to certain limit. Right. Right. These are all the see here height. Right. Absolute right. Who is number 351 lateral entry? Sanjay Raju. Height. Right. Correct. Absolute right. Height. And also one person said that 313 position. Position. These two are right. So of course, maybe some of the persons up to certain limit change of initial position from initial position changes, right? So here, the level means it is the height of a liquid. That means here the position changes. For example, in a container or in a vessel, some liquid medium is there. In that, how can you find the level means it measures the height from the datum line or the reference line. From the datum line or that means it measures the height, yeah, the height or a position in the container or the position in the vessel, position or height with reference to the datum line or with reference to the baseline of that particular container or a vessel. So that is called a level. Right? You can get the clear idea. Here some disturbance is coming with video due to net slow. Automatically the video is dropping down. Okay. See here in this, what we are discussing in this level, that means it mainly depends on the height or the position of a liquid which is containing in a vessel or a container. We have to measure with the reference of a baseline or a datum line. So that is called a level. So correct, now it is correct. In that level measurements, we can go for direct or indirect. Now, next slide, we will discuss it. Next, flow measurement. What is a flow measurement? Anybody flow? Anybody flow? So level is over. Next, about the flow. Flow. Flow chapter. Anybody can tell me. Somebody said about level. Okay, right. Around 7 or 8 members said that. In that, 2 members. Okay. And then about flow. Flow means somebody said that velocity of the material, moving, passage of matter, moment of liquid. Right. Uh, somebody said that in Telugu, in English, that is pravaham. So moment of liquid, continuous motion, right? Continuous motion. Here, flow means somebody, of course, moment of liquid and passage of matter, moving, continuous motion, kinetic energy of molecules. So okay, these are all okay, right? Flow means, in other words, we can say that it is the motion of a, it is the motion we can call as a moment of a some moment velocity. Then here see velocity of flowing liquid, right? Velocity of flowing liquid, velocity of liquid, continuous motion, uh, right? So here flow is nothing but it is motion or movement. Somebody said that the moment of a liquid, motion of a liquid with respect to time is very important. Here, flow means always we have to go for with respect to time. The rate of movement of a liquid. The rate of a movement of a liquid. In other words, we can also call it as a discharge. Discharge. The rate of movement of a liquid or the flow rate. Simply, we can also call it as a flow rate. Say that measurement. For example, here when you open the tap, what happens means in our household, the water falls into the bucket. That means here flow takes place through that small opening of the tap. So that means a flow. So how much flow is that means flow is always measured with respect to the rate. Rate means with respect to the time. With respect to the time, rate of flow of a liquid. Always the flow is nothing but one motion of a liquid with respect to time. That is correct, the flow. And about the speed and velocity of a flowing fluid. Velocity, right? Here one person said, of course, maybe velocity of a flowing liquid, right? Correct. Of course, it should be matched, right? Correct. It should be matched. In can also go for, in other words, velocity means it is nothing but flow only with respect to time. But here velocity in that case it is a distance, but here it is not here distance. Here we are taking considering with respect to time, but it is a flow, that is a quantity of a liquid flowing, quantity of a liquid. It means a discharge. All of you know the discharge. Uh, what is the units of discharge? Meter cube per second. The quantity, how much a quantity will flow with respect to time. And speed is nothing but what you know that very well. Speed is nothing but it measures the a part or a moving body. It moves some particular distance with respect to time. That is called a speed. Speed. That means a speed. For example, rotation of a shaft. Right. We can find out the speed in angular motion. That is a revolution per minute or RPS, revolution per second. You can go for speed. That is speed. I think the speed, all of you know that. No, you got a conclusion, right? Now we'll go for uh, measurement of liquid level. Here, the liquid level refers to the position or height of a liquid surface from above a datum line, or otherwise with respect to the baseline. So, what we discussed in the earlier about this one, it is refers to the position or the height of the liquid surface with reference to the base or with reference to the that is above the datum line. And level measurements are made to a certain quantity of the liquid. Somebody said that quantity of a liquid, certain limit. Somebody said that almost all it is nearer to that. Actually, liquid level refers to the, that is the actual definition. And here the liquid level measures that measurements are made to certain quantity that indicates certain, for example, in a tank so 1 meter is filled, means the 1 meter of height is filled means with water. Then we can say that means a certain quantity of liquid is held in the tank or held in the vessel or held in the container. So quantity, this one who can relate it with the quantity. And level offers both the pressure and rate of flow in and out. That means here the level here mainly depends upon the pressure and the rate of flow. That means, for example, in a water tank, here the water is filling through some pipeline into the tank. That means rate of flow in. And we are using, for example, take in our household appliances. At the top floor tank is there. So here we are filling the tank with the help of the by switching on the motor, and then what happens means the water falls into the tank. That means um, 1 minute, Nana. Okay, right. See here in the next here level offers both the pressure and rate of flow. That means rate of flow in and out of the container. Rate of flow, that means water falling into the tank, and then water is utilizing out. That means coming out from the tank. That is rate of flow in. It is mainly level depends upon rate of flow in and rate of flow out from the container. That means in a container, for example, in a container, this is a container. Example, this is a container or a tank. Here the water falls from this pipeline, right? So here water falls in the pipeline means what happens means water falls, right? The waterfalls, what happens means that the level, that means the height of the liquid in a tank changes. That means it is a this level mainly depends upon the rate of flow in the tank and out of the tank. So here some of the water is utilized for some other purposes. Then what happens at the level changes, the level in the tank change. That means here the level in the tank varies, that is the rate of flow of in into the tank and the rate of flow out of the tank, and also the pressure. Here the pressure means sometimes for example, if the out of the tank, for example at this end, for example at the out, here one valve is there. Here when you rotate the valve, for example one rotation and two rotation, what happens means the speed of the flow increases, one that may thereby the pressure changes. So here the it mainly depends, the level is mainly means depends upon the rate of flow in into the tank and the rate of flow out of the tank, right? And also the pressure. And here the task of the liquid level measurement may be accomplished by in two methods. One is a direct method and the another one is indirect method. See here the direct method, all of you known that, see here in the direct method, all of you known. So 1 minute. Right. And here today is disturbing. Here the environment is not good. So in Tadapalligudam, from morning onwards, environment is not good. So some disturbance is coming in the network issues. So okay, now it is clear to all members. It is clear. Members know if any disturbance will occur, means let me know, right? Uh, and the next in the direct method, see here in this direct method, there are these are the several types are there. Hook type level indicator, side glass, float type, float and shaft liquid level. Actually, this is not in the syllabus. But anyway, I will explain you some of the direct methods of measurement of direct method. I think all of you know that. So here one method is not written here. Dipstick method. Dipstick method. That means in a tank containing some liquid, you can measure directly by dipping a scale. By dipping a scale. So that's why it is called a dipstick method. So by dipping a large scale, then what happens? So we can measure the level directly by making the mark. So that is a direct measurement. This is one of the direct first methodology to measure the height of the liquid in a tank. So that means directly we are implementing the scale into the container containing liquid whose level has to be measured. Then what happens wherever that liquid is marked, that indicates the height of the liquid in the tank. That means the level of a liquid in a tank. That is actually direct method. And then here this side glass, float type, float and shaft liquid gauge. These are the things. Actually, these are all direct methods. But this is not in the syllabus. Remember this point. Here, this is not in the syllabus. Only the syllabus, five devices are there, five sensors are there. Those five sensors are indirect methods only. That means you cannot take directly. That is, those are indirect methods. So I will explain you some two examples. This see here in the site class, right, or of an Indian that means side glass in an open tank. So here in the side, what happens means one glass tube is there. This is a glass tube, site glass tube. This is a glass tube. This is a glass tube. Here, when the level of the water increases automatically, same uniformly, this level also in the glass tube side of that tank, that is also rising. So here, so for that glass tube, we have to attach one scale so that we can read it directly. So this is a direct method. So actually, it is there in our lab. You can go for it. Is a MOS lab that is in rotometer in the side. It is there. We can easily see that. Even in FMHM lab also, you know that the tank is filling water. The side when the water is rising automatically, you can contact with a scale directly. It measures the that means the level of the liquid or the height of the liquid in the tank. This is direct method. And the float, this is also, see here, in this, we are arranging a float or a bob. This is a float or a bob. Here, when the level in the tank increase, that means here one end of the rope is a float here we are attaching, and the other end we are adding a counterweight. That means to make the rope tight, that means this rope is carrying by a pulley. This one we can call it as a pulley. This is pulley. And then see here, when the level of the water in the tank rises, this bob or the float also rises. Thereby, what happens means the counterweights will move in this direction, which in turn, this rope moves the pulley. Thereby, here the pointer moves on the scale, which indicates the level of a liquid in a tank. Level of a liquid in a tank. So now here again I'm explaining clearly. Actually, this is not in the syllabus. Direct methods is not there in the syllabus. Just for understanding purpose, I'm explaining two methods, two or three methods. One is a deep stick method. Another one is a side glass for an open, in an open tank, and then float operated liquid level. Right. So here in this one end here in the consists of a rope. One end of the rope here we are attaching a bob or a float, and the other end we are placing a counterweight to make the rope tight, which is rolling on the pulley. And then here, when the level in the tank rises automatically, the bob also rises up. Here, with this, which in turn, here the counterweight will move down. Thereby, the this rope, which in turn moves the pulleys. Thereby, which in turn the pointer moves on the scale, which indicates the measurement of level. So now it is clear. Next, we will go for capacitive, right? We will go for capacitive. Capacitive. This is indirect method. Capacitive level sensors. In this capacitive level sensor, see here. This is if you observe clearly in the capacitive sensor. Here in this, it consists of a capacitance probe, and some electrical wires, right? And then here one meter indicates this indicates it is a calibrated liquid level, that meter. And then here it consists of a tank. See here, this is another figure, same figure only, but it indicates in a different way, but the explanation is same. And here it consists of a tank containing liquid whose level has to be measured. Here, this is a liquid level in a tank. We have to measure. So now here, if you observe clearly, the output here in this, the output is nothing but we have to connect with the help of, this capacitance that means a device with the help of the electric wires. That is the output here. This output is nothing but this is right. Hmm? Then next here, this capacitance is mainly depending upon this formula. All of you know that C is equal to epsilon naught R, epsilon naught, epsilon R, A by T. We can also call it as A by D. Area is nothing but the area. All of you know that T or D. We can also call as a D. Distance between the two plates. See here, when you observe here, these are the two plates. Here, these are the two plates of the capacitors. Here, if you observe clearly, when the level of the tank rises, for example, if the level of the tank rises, the medium between the two capacitors changing. See here, once if it is level is at up to this means the medium between the two capacitors, that means the liquid is occupies up to this point only. Here the that is the dielectric, that is medium between the two capacitor plates changes when the level of the liquid, that means height of the liquid changes. That maybe increases or decreases. So now you got it. See here, here the level of the liquid is at here. Here here the all of you know that the capacitance is mainly depending upon the distance between the two plates, area, and the dielectric between the two plates. Here the medium is liquid. For example, we can consider water. If the level increases automatically, what happens up to this portion here, the between the two plates, the portion of the dielectric varies, the dielectric amount. So the here when the level of the liquid varies, automatically the dielectric also changes. Once the dielectric changes, that means the capacitance is mainly depending upon the dielectric. The capacitance also changes. That should be indicated in the reading yet here. That capacitance we can give a calibration. It calibrated directly. It measures the level of the liquid in the tank. It's very very simple. See here, these are the insulated metal electrodes. You can also call it insulated metal electrodes. Right. Now you understand this one. Advainama? Or you understand? Or you understand? Any questions? Okay, Mr. Naveen. So you better inform to your class teacher, uh, right? Hmm? Okay, BN will get better information, uh, give information to the right to your class teacher, right? Naveen, Naveen, what is your number? Here a problem is coming for the video. Okay, number Naveen, 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 M Naveen. I'm asking about M Naveen. Right. Your lateral entry 30, 330. Okay, give number to him. So, great. Take care. And then next, some person asked that A and T or no. Here, A and T are constant. Of course, maybe. Here, the distance between the plates is not changing. Here, the distance between the plates is not changing. Of course, maybe constant. And T is nothing but distance. You can call as maybe it as a T or D. And area, that means the area we are not moving the plates. We are not moving the plates. The overlapping area between the two plates is same, right? Here the changing of the parameter is only dielectric. That is the level of the liquid changing. If the level of the liquid changes, automatically the dielectric between the two plates is also varies. Here, if the height is at here up to this portion only is dielectric, right? And the remaining portion is here. For example, if the level of the liquid is at here, then the dielectric changes again up to this level. The medium is changing, right? So if the medium is changing, automatically the capacitance varies. Can we use in automobile fuel level measure? Yeah, of course, maybe in our water tank, in our bike, here tank is there. Actually, that is nothing but bob. We are see here that arrangement is a bob arrangement, a float level arrangement. It is what I said in the previous. That is float, right? So that arrangement here we are using in automobiles fuel level measurement. Okay, and 1%. Then how to increase the liquid level? So how increase means how to we cannot say. So if you need, for example, if the level of the liquid in the tank decreases, then we have to make to fill. That is make to fill. So for certain utilization purposes. Okay, right. Maybe some of the bikes it is used. Okay, right. You said, Mr. Syam, Lateran T32. Maybe Royal. See here in my bike, that is a Passion Plus. What I observed, it is a bob arrangement. But maybe Royal Enfield bike, it is maybe it is used capacitance and transducer maybe uses. Maybe it is used. Okay, Mr. Shyam Sundar. And what area is considered here? Here, these two, the area means is constant. Lateral 39. Here the area there is no change. When the here in the formula A indicates, for example, one plate is there, the other plate is the two plates are there like this, right? Two plates. This is the two plates. Both are parallel to each other, so that's why we can call this as a parallel plate capacitors. So, for example, if these two plates is like this means the overlapping area is there is no change. For example, one is fixed, another is moved means then the overlapping area. This is the overlapping area. This is the overlap. That means this is the overlapping area, right? So that area changes in some cases in some particular applications. Okay, Sunil. And the next we'll go for the next ultrasonic. This is the explanation now what I given. So that means we can call as a sometimes here if you see here the two plates are clearly visible, but here in this only probe in the inside the probe two parallel plates are there. It is fixed. This is a probe. We can call it as a probe. We can call it as a this is a probe. Here the this one is a the small rectangle, right? This is nothing but a probe. For understanding purposes, I written the figure clearly, right? So the same explanation. So, sir, this is the explanation. Now we'll go for ultrasonic level sensors. So here in the ultrasonic level sensor, in this it is used where the very hot liquid is very too high temperature. It's very difficult to measure the level at that particular situation. We can go for ultrasonic level sensor. And some of the liquid very in a molten stage. For example, if you go for in Vizag steel plant, here the molten metal at very high temperature it is flowing, right? Maybe in a tank or some other. So we have to measure the level of that particular molten level. It's very difficult, the molten state. Maybe you're right, correct. Use for sea depth, right? Of course, maybe sea depth. Yeah, right. Okay, sea depth. Okay, sea depth, right? Correct, Mr. Sunil. Sunil, you are right. The next is here in this this ultrasonic level sensor is used to measure the uh, level of a liquid in a tank or a vessel. See here in this, it consists of a liquid whose level we have to measure. So here ultrasonic, see if you observe here ultrasonic pulse source. Here one arrangement is there. We can call it as a T, ultrasonic pulse source transmitter. That means it transmits the ultrasonic sound waves. We have to arrange it at the top of the tank. One side of ultrasonic pulse. That means it that is the source. It transmits the ultrasonic sound waves. So and then so we can call this is as a T, and this one we can call as a receiver or right. So here when the ultrasonic sound waves hits the that means it strikes the surface level of a liquid, and then again it reflects that sound waves and it is received by a receiver. It is received by a receiver. So this taken some period of time. See here, when the ultrasonic sound waves are released or transmitted, it strikes on the surface or and it reflects from the surface of the liquid, and then it received by a receiver. This process will take some time. This time period is calibrated in terms of the level of the liquid in a tank. Level of the liquid in a tank. Okay, 1 minute. సార్ గోపాలకృష్ణ గారు.
సార్ గుడ్ మార్నింగ్ సార్.
సార్ గుడ్ మార్నింగ్ సార్. నేను క్లాస్లో ఉన్నాను సార్. నేను కాల్ చేస్తాను సార్.
ఓకే సార్, ఓకే సార్, నేను మళ్ళీ చేస్తానండి సార్.
ఓకే
ఓకే సార్,
ఓకే
ఓకే సార్.
ఓకే సార్. And then see here in this transmitter and receiver. For example, if the level of the liquid is at here means the time period is more. The time period is more means then the level of the liquid, the level is less. The time period is very less means then the level of the liquid in the tank is high. So that is the indicates here. This indicates again. I'm repeating all of you. See here. Here the ultrasonic sound waves are released, and then it focuses on the surface of the that is a liquid in the container or a vessel. Then it reflects. The sound waves reflects, and then it is received by a receiver. This process will take time. That time period, whatever the time calculation, that time is calibrated in terms of the level of a liquid in a tank. And that is we can also call it as ultrasonic liquid level gauge. Right. I hope so you understand, right? Right. This is the explanation. And then advantages. Here, this operating ultrasonic is very simple. It can be used for various types of liquids and solid substances also. See here, this ultrasonic, here we can go for, this is both capacitance and ultrasonics. In capacitance also, it is used to measure the height of the liquid as well as some solid powdered, some solid powder in the solid form. That also we can use with the help of the capacitance level transducer, right? And this is also liquids and solid substances, some solid substances. And a very expensive and very experienced skilled operator is what I said that somewhat the cost is also very high. Very experienced and skilled operator is required for the measurement of the liquid. Yes, time proportional to the depth of the liquid, right? Correct. And ultrasonic sensors, so these are used, level sensors are used in many applications. What I said that to measure the hot liquid level, and these are also used in within the food and beverages to measure the liquid level in bottles, and it can be used within the manufacturing for an automated process manufacturing in any automation. These ultrasonic level sensors is used especially in industries. So, for example, in the boiler containing liquid, so how much level? Of course, maybe the boiler is it's completely closed. It's very it's very too hot. Then we have to measure with the help of this ultrasonic level sensor. So by sending the sound waves, and then we can, with the help of the time period, then we can calibrate the level of the liquid in the boiler. Submarines, okay. And now I will take the attendance. You can respond one by one. So respond attendance one by one. 18th, it's 1 minute. Right, 18th batch 320 and 18th batch 381. Right, number 1, 2, 3. Paper. 3, 4, 5, 5, 6, 6, 6, 7, 7, 7, 8, 9, 9, 9, 9, 10, 11, 11, 12, 13, 14, 15, 16, 16, 17, 18, 18, 18, 19, 20, 21, 22, 21, 22, 23, 24, 25, 25. Right, 26, 26, 27, 28, 29, 27, okay, 28, 28, 28, 29, 30, 31, 32, 33, 34, 34, 35, 36, 36, 37, 38, 38, 39, 40, 41, 43, 41, 43, 44, 45, 46, 47, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 57, 58, 57, okay, 58, 59, so 59, okay, 60, 60, 61, right, okay. The next lateral entry 1, lateral entry 1, 2, 3, 4, 4, lateral entry 4, 5, 6, 6, 7, 8, 9, 10, 10, 11, 12, 11 absent, lateral entry 11 absent. Like 12, 13, 14, 14, 11 present, 15, 16, 17, 17, 17, 18, 19, 20, 21, 22, 23, 24, 25, 24 absent, 25 absent, right, 26, 26 lateral, 26 absent, 26, 27 present, okay, right, 28, 29, 30, 31, 32, 31, 31 absent, 33, 33, 34, 35, 36, 37, 37, 37, 38 option. 37, 38, 39%. Okay, right. 40, 41, 42, 43, 44, 45, 46, 47, 48, 47, 48, 47 option. 47 option. Okay, 47, 48, 49, 48 option, right? 50, 51, 52, 53, 54, 55, 56, 56, 57, 56 and 57, 56 and 57. I'm asking about 56 and 57. 56 and 56, both are options. Here, see, I'm telling here the regular 1, 2, 9, 11, 21, 22, 35, 36, 41, 47 absent, and 36 present. Okay, 307 present. Okay, here regular absent is uh, 1, 2, 9, 11, 21, 22, 35, 41, 47. And lateral entries section B 4, 18, 24, 25, 31, 37, 38, 48, 56, 57. 38 present, huh? Okay. 38 present and 18 lateral entry present, okay. And 17, okay, present. 28 regular present, okay. And lateral entry 21 present, already present, okay, right. Okay, thank you to all of you. 37 lateral entry present, huh? Okay. Okay, 38. 7 lateral, okay. Okay, thank you all of section B lateral entry. Absentees are 4, 24, 25, 31, 48, 56, 57. Okay, 338% regular. 45 regular present, okay. And 59% regular. 25 lateral entry present. Okay, thank you to all of you. 53 present more regular. Okay, thank you to all of you.